discussing about thread life cycle. The thread have the life cycle like new, runnable, running, blocking or blocked, or you can say waiting, terminated. New meaning a thread begins its life cycle in the new state. Thread remains in the new state until we call the start method. Runnable, after calling the start method, thread comes from the new state to runnable state. New state to runnable state. Running meaning thread comes to running state, and when a thread scheduler pick up that thread execution. Next we have waiting or sleeping. We can say sleeping, waiting or sleeping. So here a thread in waiting state, in waiting state, in waiting state. So if it wait to further another thread to complete its task, if it waits for it waits for another task, another, I can say, another thread to complete its tasks. So like for example, in the program there are multiple logics will be there. So if you want to run all the multiple logics parallelly, and if you want to wait some, you can have the option that is the sleep options, and then you can have the options, you can stop, you can wait the threads as well, you can wait the threads as well. And next we have the terminated, the like the last stage of that that is the termination. Termination meaning a thread enters into the terminated state, and once it's completed its tasks. Okay, a thread enters into enters into terminated state, terminated state once it completes its tasks. But once it's complete its tasks. This is the life cycle of threads. This is the life cycle of thread. I hope everyone is clear with my points. What is thread life cycle? Thread have the life cycle. There are 5 thread life cycles like new, runnable, running, and I can say blocking and terminating. This is the life cycle of this. New meaning the initially the thread will be in the new state, and the runnable meaning so until you call the thread will be in the new state. When you call the start method, then thread will move from new state to runnable state. Okay, and so immediately we have the thread scheduler. Thread scheduler is the program which is available in the JVM, and when you call the start method, and it will scheduler will come into the picture, and then it will pick up one thread, and then it execute that specific thread. Then the thread will move to runnable state to running state. Next waiting, or if any other thread is running, so at the time, so parallelly the thread will wait, and once another thread task will complete, then it will start its execution. And last we have the termination. A thread enters into the terminated state once it's complete. What Once it's complete the task, then the thread will go to the terminated state. Terminated state. Okay, fine. I will write a program on it, and then I will show you. You will get the clarity on it, like waiting meaning how the thread is waiting for execution of at the time of executing another thread. I will show you the programmatically. You will get the clarity on it. Okay. Okay, now I will go to yeah. So this is the program. Now I want to, if I run this one, this is the thread one I am giving. So what we can do, this is the thread one and T1 dot thread start, and I want to know the details of this thread. So if you want to know the details of that thread, then you can mention thread dot current dot current thread dot get name. Get name is the method which is used to know the name of that thread. Okay, now I am saving this one, and then if I run this one, now you can see which thread is executing. Click on that. Thread 0 is executing. Thread 0 is executing. Okay, thread 0 is executing. Thread 0 is executing. Okay, I'm running this one now. See thread 0. I don't want to this the thread 0 name. I want to give another name. So if you want to give the name of that thread, then you can mention t1 dot name, t1 dot set name, set name. Okay, here you can set the name. For example, I would like to give first thread. Like that, I am giving the name. The names you can give anything, guys. Okay, first thread, first thread. Okay, fine. I'm saving this one, and then I'm running this one. You can see here. Here you can give. Yeah. So I'm doing small changes. The small changes are, I would say, yeah, fine. Now I'm saving this one. Okay, I'm saving this one, and now I'm running this one. Now you can see first thread run method executed, run method started, run method started. Okay, fine. Now I would like to create one more thread. The same, I would like to create one more thread. Thread thread T2 equal to new thread, and T2 dot, we can call the start method. Start method. Okay, next T2 dot T2 dot start method called, and we can mention the name T2 dot set name. So here I'm giving the name like as the second thread. I'm giving the name as second thread. Second thread. I'm saving this one, and click on this. Click on this. Here you can give the input as which is some DT. Now you can click on that. First thread executed and second thread also executed. Second thread also executed. Like that, I'm creating one more thread, and that I can mention like as the T3. I'm mentioning like as the T3 dot start, T3 dot set name. Okay, now I am running this one. You can see here I'm mentioning like as the third thread, third thread. Okay, so when I start the threads, and the scheduler will execute come into the picture, and it will pick up the threads one by one, and it is executing and it is displaying the results on the console. That is the process internally happens. First thread, third thread, and second thread. Now you can see here the execution. I call the ordered, like T1 I called, T2 I called, and T3 I called. But if you see here, at the time of execution, at the time of execution, so here the point is the execution not under the control of developers, not under the control of a programmer. So when you start the method, and thread scheduler will pick up a random scheduler, and then it will execute. Random scheduler, and then it will execute. So here we don't have any controls on the printing or the results. Okay, only we will start the methods, and then when we start the start methods, then thread scheduler will come into the picture, and it will pick up the threads, and then it will execute. It will execute. Okay, now I am if I run multiple times, you can the order might be also changed. Now you can see here second thread is printing first, and third thread thing is printing first, and like that the order is changing. The order is changing. Okay, the thing is, so this order, who is responsible this order? We are not responsible this order. So when you call the start method, thread scheduler pick up thread scheduler pick the threads, and then it will execute, and then it will execute. It will execute. Okay, so this is under the control of thread scheduler. So that is the default available, the thread scheduler which is available in the JVM. And when you call the start method, then the thread scheduler will come into the picture, and then it will pick up the threads, and then it will execute the threads. Okay, this thread execution we are not responsible. Okay, so thread scheduler will responsible. So that is also, it will pick up randomly, and it will print randomly on the console. Randomly on the console. Okay, fine. This is, I hope this is clear. Now here we have the thread priorities. Thread priorities. For example, there are three threads. Now I want to print this thread as the first one, this thread as the first one. Then you can set the thread priority. Thread priority meaning we are requesting to the thread scheduler. We are requesting to the thread scheduler. For example, T3 dot set priority. Set priority. So in the thread priorities, the maximum number is 10, and the minimum number is 0 or 1. Okay, and the normal number is 5. The normal number is 5. For example, here I would like to mention 10 priority. 10 priority. Now I am saving this one, and by default remaining all are the priority is 9. The normal priority is 5. I am mentioning this one as the 10. Now if I run this one, you can see here priority meaning I am requesting to the scheduler, thread scheduler. So you can print this one as the first, and remaining two schedulers you can print later. You can print later. So that I am priority meaning requesting to the scheduler. Priority meaning request to the scheduler. Now here I will show you thread priorities. Thread priorities. Yeah, see here thread dot minimum priority is 1, and maximum priority is 10, and normal priority is 5. You can see here by default each thread is given a priority 5, which is represented by the normal priority, but it can change. We can assign any priority to the thread, any priority to that thread. Okay, okay, fine. You can give the numbers, or you can use thread dot maximum priority. Thread dot maximum priority. Maximum priority meaning we are requesting to the scheduler. Now here this one I would like to mention like as the normal priority. Normal, these both are by default there are normal priority. This I can mention like as normal priority. Thread dot normal priority meaning which is equal to 5, which is this is the set name, right? T2 dot get priority. Mention here the get priority as thread dot minimum priority. Set priority, not get set priority. Okay, fine. Similarly, here you can mention this. Here you can mention like as the normal priority. Then I can mention like as the normal priority. Normal priority. Okay. Priority is meaning we are requesting to the thread scheduler. We are requesting to the thread scheduler. Okay, so thread scheduler will pick that threads based on the priority, and then it will execute. And then it will execute. Okay, and then now I am saving this one. Now you can see. Now you can see. So this is all about thread priorities. Thread priority meaning we are requesting to the thread scheduler, and based on our request, thread scheduler will pick up our threads, and then it will execute the threads. It will execute the threads. So that is called thread scheduler. That is called priorities. Priorities meaning we are requesting to the thread scheduler. We are requesting to the thread scheduler, and based on our priorities, thread scheduler, I would say thread scheduler will pick up the threads based on the priorities, and then it will execute the threads. And then it will execute the threads. Okay, this is all about thread priorities. And so after that, so in that we discussed about what is thread scheduler and thread lifecycle. And next we discussed about I would say thread priorities. I hope you guys clear with this priorities part, right? Next, actually we have the concept that is actually uh, that is synchronization. What does it mean by synchronization? And that we'll see about the synchronization. Next one we have the topic that is synchronization. Synchronization. So in the synchronization, so already we discussed about the term about the synchronization in the string concept. So string is at the time we discussed about string is the immutable. It can hold only one value, meaning it can only fixed values. We cannot change the values. And string have the siblings that are like string buffer and string builder. Few of the points we'll discuss about at the time. String buffer and string builder, and string buffer and string builder, they both are mutable. The both are mutable classes. This one is also mutable class, and we can change the manipulations, but we can change the manipulations. Only there is a little difference between the string buffer and string builder. String buffer and string builder, there is only the difference between the string buffer and string builder. So this one is the synchronized synchronized class, meaning this is the thread safe, this is the thread safe, and this is non synchronized, meaning this is a not thread safe. Not what is thread safe and what is non-thread safe, meaning thread safe meaning only one person can access. I will tell you a small story here. You will get the better clarity on that. For example, so in our class, so I bring a sweet box for you. You can assume I bring a sweet box for you. So and then I announced in the class, hey guys, and today is my birthday. So for that occasion, I would say I bring the sweet box for you. So in the class, you can assume there are 10 student. There are 10 student. Okay, there are 10 student will be there. There are 10 students. The sweet. These are the sweets. I bring total 5 sweets. 2, 3, 4, 5. The students. There are 10 students. Um, okay, so I announced in the class, hey students, today is my birthday, and for that I bring a sweet box for you, and then you guys can come and then can bring the sweets. 2, 4, 4, 6, 8. We have to take 2 more persons. Okay, there are 10 students will be there, and I bring the 5 sweets, and then I announced in the class, hello students, please come and take your sweets. Then in that case, what might be the possibilities? We can normally can assume what might be the possibilities. Possibilities are there are only 5 seats are available, and there, so if the first person will come, and there is a chance of the first person might be the bring 1 seat, or the first person there be a chance of to bring the 2 seats also. 2 seats also the person might be bring. Okay, there is a chance, and if the person bring the 2 seats, then only 3 persons, the 5 seats are enough for only 3 persons. Then how we can overcome this issue? Now this is the case number one. Now I will keep there are 10 seats instead of 5 seats. I will keep the 10 seats. Okay, now the same thing I announced in the class, guys, can you please come and then bring the take the sweets one by one. In that second scenario, what will happen? There is a possibility of this person might be pick 2 sweets, and this person might be take 2 3 sweets. There is no guarantee, right? There is no guarantee. Okay, so in this scenario, like in this scenario, how we can write the program? So there are in this scenario, normally how we can write the program, meaning there are total 10 students. 10 students meaning we will create 10 students is equal to, we will create 10 threads. We will create 10 threads. We will create 10 threads. Okay, sweet box meaning sweet box equal to sweet box meaning that is the a resource, or you can say object, or you can say object. Next up, next up. So here the thing is, when the multiple when when the multiple objects are working, when the multiple threads works on the same object, works on the same object, works on the same object, then same object, there is a chance of getting data inconsistency problem. Then there is a then there is a chance of getting then there is a chance of getting data inconsistency problem. Data inconsistency problem. Data inconsistency problem meaning inconsistency problem. Data inconsistency problem meaning reading the wrong data. Reading the wrong data is called data inconsistency. Reading the wrong data. Reading the wrong data is called data inconsistency problem. Then how we can overcome this problem? That problem we can overcome by using the concept that is the synchronization. Synchronization. Are you guys clear with my point? The point here it is. So there are 10 students will be there. The sweet box also there are 10 sweets will be there. So I announced in the class, guys, can you please come and then pick the sweets. Pick the sweets. In that case, there is a possibility of, so one student might be picked two sweets. There is a possibility of one student might be picked the three sweets also. Okay, there is no guarantee. Okay, then how to overcome that issues in the programmatically? That's how the synchronization topic. That we have the synchronization topic. So when the multiple threads works on the same object, then there is a chance of getting data inconsistency problem. Data inconsistency problem meaning reading the wrong data is called data inconsistency problem. Then how you can overcome? Then how you can overcome? This I will show you. I will write a program on it. You will get the better clarity on that. Okay. Now actually I will take one method, and that I can take a few of methods, and then I will show you. You will get the better clarity on it. Okay. Okay, same program I will do some changes. Here I am taking one more method. The method I am mentioning like as printing numbers. Public void print numbers is the method, and from here to here this is the scope of the method. And inside what I am doing actually, so I remove these all things. Okay, fine. Now as of now is clear. So when you using the runnable interface, so run method you have to take. Okay. Now I am taking the method. The method name is public void print numbers method. Print numbers method. And from here to here, this is the scope of the method. And here I want to print by numbers from 1 to 10. 1 to 10. If you want to print the numbers 1 to 10, normally we will use the for loop, right? We will use the for loop, and in that for loop, we will write the initialization int I equal to int I equal to 0, and condition and increment or decrement. Okay. Now here I would like to take the sysout statement. if I mention I, meaning if I okay run method, and inside the run method what I am doing, I am mentioning method, that is print num method. Okay, fine. Now here I am creating main method. Inside the main method I am creating the demo object for test dt equal to dt or d equal to new demo test. Okay, fine. Okay, now we can create the thread. So if I run this one, it won't execute by default. It won't execute by default. So for example, if I run this one, it is printing anything? No, nothing is print, because by default it won't execute. You have to call to the start method. Thread t equal to, I'm mentioning like as t1 equal to new new thread new thread. Okay, fine. Now I'm saving this file. Now I'm running this one. You can see here t1 dot, you have to start the thread. T1 dot start method, T1 dot start method. Okay, T1 dot start method. T1 dot start method. The method name is print num, and you can check initialization I equal to 0, I less than or equal to 10, I plus plus. Okay, fine. And we are calling the T1 dot the start method. T1 dot start method. You can save the file. Run this one. So here we can pass as the input T. Run this one. Now you can see the values are printing from 0 to 10. But here the values are printing. I want to print the values with some time, meaning so when I run the program, it is directly printing. I don't want to print the directly. I want to print with some time. So if you want to print some time, then what you can do, you can take one try block. So I would like to take some try block. So inside try block, I would like to mention sleep thread dot sleep method. So here I am mentioning some 2 milliseconds. 2 milliseconds meaning 2 seconds. If I mention 1 milliseconds meaning 1 minute. 1 minute. So here you can catch the exception. Catch the exception. From here to here, you can catch the exception. Exception name and exception equal to dot print status. Okay. Okay, fine. Now you can see if I run this program, after second 2 is printing, after 1 second, so like this it is printing. That is also okay, very good. That is also okay, very good. Now I want to know which thread is executing these numbers. So if you want to know that one, then you can mention thread dot current thread. Thread dot current thread. Current thread dot get name. Get name. Okay, and okay, fine. Now I'm saving this one and I'm running this one. So by default name is the thread 0 is the name. Okay, I don't want by default name. I want to give my own name. I want to give my own name. Then what you can do? Mention set name. Set name. Okay, so here simply guys thread topic is very easy. Please concentrate. So the thread name I am mentioning like as the print numbers first thread. First thread for printing numbers. First thread for printing numbers. Printing numbers. Okay, I'm saving this one and I am running this one. You can see first thread is execute. Okay, this is also okay, very good. Now what I am doing, I am creating one more thread. I am creating one more thread. I am mentioning the name as T2, and here also I am mentioning the name as T2, and here also I am mentioning the name as T2. Okay, that is also okay, very good. Here I am mentioning like as the second thread print numbers. Okay, now I am saving this one, and you can see now how it is executing. So I created, there are two methods, two threads I created. I will create third thread also. Third thread also I will create. Now you can see here I created, there are a total 3 threads actually. Okay, fine. I created total 3 threads. Okay, I am running this program and you can see here second, first, second is first, second. So it is printing uh, randomly. It is printing randomly. But I don't want like this. I don't want like this. I don't want like this. Meaning, if you go with this approach, this is non-synchronized. Non-synchronized, meaning it is picking some random data. So if you go with this approach, you might be get the data inconsistency problem. So that is the reason what I will mention like as this block. I will mention like as the this block I will mention like as the synchronized. Synchronized is the keyword. Synchronized. Synchronized is the keyword. Synchronizer is the keyword. I'm saving this program. Now I am running this program. Now you can see first thread is executing, and once the first thread execution is completed, then only second thread will start. Second thread will start. So that is the advantage with the synchronized keyword. That is the advantage with the synchronized keyword. Okay. So we'll discuss few points about synchronized. How to achieve synchronization. Achieve synchronization. How to achieve synchronization. So synchronization we can achieve in 2 ways. One is using synchronized method, using synchronized method, and the second one is using synchronized block, using synchronized block, using synchronized block. Block meaning normal block you can take, and then this is called method level. This is called method level, and this is called block level. This is called block level. This is called block level. Okay. This is called block level. Now this is the simple program for, I would say, synchronization. So like that, normally if you want to book a bus tickets, so everything we will use the threads. Everywhere we will use the threads. Now I will show you few of the programs on that threads. Mm, Java programs with synchronization keyword. Normally block meaning this is the scope of the curly braces and this is the scope of the curly braces. Normally block meaning, so block meaning from curly braces and closing curly braces is called, this is the normal block. This normal block if you mention like as a synchronized, then that is called synchronized block. Synchronized block, and normally here we can pass some object. This is called synchronized block. This is called synchronized block. Okay. Normal there are problems will be there with related to like bus tickets, movie tickets, and then some railway tickets. So like these all are working based on the multi-threading only. For example, you can assume there is a one seat and coming we have the Pongal festival. So most of them they would like to go to their hometowns. So can assume there is a limited buses and that they have only one seat, and then that seat there are multiple people they're trying to book that ticket, and then at a time only one person can able to access. If the ticket will book for two three peoples, then what will happen? some disputes will come. Okay, so everywhere we will use the multi-threading. So these are the programs you can practice multiple programs on this multi-threading by using synchronization. By using synchronization. By using synchronization. Okay, so in the multi-threading topics, what are the topics we covered? Topics we covered like what is thread and what is task, what is multitasking, and types of threads, a user defined thread, and how many ways you can create the user defined thread, and what is the thread scheduler, and what is the life cycle of thread scheduler. I would say thread life cycle, and what is synchronization keyword, and what is priorities. Priorities meaning priorities are the request we are requesting to the thread scheduler. Based on the request, thread scheduler will execute, and then it will pick the I would say threads, and then it will execute, and then it will execute. So in the synchronization, what you guys will do, can go to that the these websites like Java T Point and all, and you can practice more and more programs on that. You can practice more and more programs on that. Okay, if you stuck anywhere, you can ping me. I can help you in that case. Okay. So today your assignment is write a program on thread priorities. That is the one assignment. And second assignment is write a Java program on using synchronization keyword. Two assignments. Write a Java program using thread priorities is the one program, and second program is write a Java program using synchronization keyword. Synchronized keyword. Okay. So all our assignments